Okay, the first equation of motion, the second equation of motion, and the third equation of motion. How do we derive these three equations of motion? First and foremost, we must first understand the acceleration. And like we defined from the previous video, you see acceleration is the rate of change of velocity. That is to say, the final velocity minus the initial velocity. So the capital V stands for the final velocity, the small u stands for the initial velocity, and the t stands for the time. Now the final velocity minus initial velocity divided by time, this is what we call the acceleration. When a body is moving at a constant acceleration, this is what we experience, so this is what we have. Therefore, if you make v minus u the subject, and you later make v the subject, you're going to have u plus 80. So this is the first equation of motion. Then the second equation of motion, we get it from the average average velocity is equals to distance all over time. Distance all over time. Or average velocity can also be equals to v plus u all over 2. V plus u all over 2. Now, since they are all average velocity, we can equate them. We can have the distance all over the time is equals to the v plus u all over 2. Now, we are interested to make s the subject, cross multiply. Of course, s will go with the 2. It's going to be 2s. It's going to be v plus u multiplied by the time. You divide both sides by 2. Divide by 2. The 2 and 2 will cancel out. Therefore, you are left with your s is equals to v plus u all over 2 multiplied by t. Once you have this now, you can easily substitute the time. You can make time the subject in the first equation here. Make time the subject. If you make time the subject from the first equation, v is equals to u plus 80, make time the subject, you're going to have 80 is equals to v minus u divided by a. So the a's will go away and you are left with v minus u all over a. This is going to be the time. Now this time you substitute it here. Once you do that, you have your distance s is equals to v plus u all over 2 multiplied by v minus u all over a. Now if you look at the numerators, you see difference of 2 squares. That's the same as v square minus u square all over 2a. In mathematics, we learn about difference of 2 squares. You apply that, or you can open the bracket. V times v is v square. V times u is minus vu. U times v is plus uv. And the u times u is going to be u square. So the minus uv plus uv will cancel out, and you are going to be left with v square minus u square. Now make v square minus u square the subject, and you are going to have 2as. Now make v square the subject, you're going to have u square plus 2as. So this is the second equation of motion. That is v square is equals to u square plus 2as. Now let's look at the third equation of motion. How do we get the third equation of motion? So from our s is equals to v plus u all over 2t. Of course, we know the v is equals to u plus 80. Equation 1, we can substitute this into this. We can substitute v is equals to u plus 80 into the v here. And if we do that, we're going to have our s. Let me put that up. We can have now our S is equals to the V, we're going to put U plus AT plus the U all closed divided by 2 multiplied by the time. So you're going to have S is equals to the U plus U is going to be 2U plus AT multiplied by T divided by 2. So this T affects everything in the bracket. We're going to have S is equals to 2UT plus AT square all divided by, so we can have divided by 2 divided by 2. Since this 2 is affecting both the two terms, so this 2 will go away with this 2, and then we are going to be left with S is equals to UT plus half AT square. This is our third equation of motion. So we have proved all the three equations of motion. Now we just have to write them down explicitly for you to see them all. So this is the third equation of motion. The first equation of motion, we say is V is equals to U plus AT is the first equation of motion. Then the second equation of motion, we said V square is equals to U square plus 2AS. So this is the second equation of motion, and this is the third equation of motion. So thank you very much. This is what I wanted us to look at. Then in our next class, we are now going to use these equations to solve some problems. Thank you very much.